is block 5 from topic 3 on page 84. For this lesson, you need a sheet of graph paper and turn to page 84. So, we're going to look at the first question on page 84. And it is going along with this image here. So I'm going to read the question. And it says that a landscaper needs to determine how many tiles will surround a 4-foot by 4-foot pond. How can you figure it out without counting each individual tile? List some possible ways. So to get your mind started, I'm looking at it. I don't want to count individual tiles. So what I see is I see a top row of 6, a bottom row of 6, leaving the sides with both how many? 4. If I already used that tile for the top and the bottom, I'm left with a 4 and a 4. So if I wanted to write an expression to mimic that, I have 6 plus 6 plus 4 plus 4. That's how I saw it at first. 6 plus 6, 4 plus 4. That was my top, my bottom, my 2 leftover sides. There are many ways to see different expressions. So I want you to look at it and try to come up with as many expressions as you can to mimic that. I'm going to take about a minute looking at this. I've had one person say, oh, well, 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, all the way till it added up to 20 blocks. But do you look at this and visually see sets of 2s? No. I visually want to make different groups of blocks and see it. Who has a way that they think is unique that they would like to share? Brady, what you got?
5 plus 5 plus 6 plus 4. I'm going to start recording again.
5 plus 5 plus 6 plus 4. Well, let's take a look at the picture. 5, well, first, I see your 6 all the way across, right? Then his 5 is here, his other 5 is here, and then what's left over? The 4. Love it. That is a beautiful equation. Any others you got? Aiden, what you got?
I don't know if it's one, but I had 12 plus 8. Are you supposed to
12 plus 8. I can somewhat see this because you saw top and bottom was a total of how many? 12. Side and side was a total of 8. I could see it. It could be broken down a little smaller like we just did, but I'm good with it. What do you have?
I had 7 plus 3 plus 4 plus 6.
Where do you look at this and see 7 grouped together? I'm just asking.
On the top.
Top is 6. Where's that extra 1?
Oh, I thought we could add it.
Oh, no. Okay. What?
6 times 2 plus 4 times 2.
All right. He solved this problem as a multiplication problem. 2 sets of 6 plus 2 sets of 4. I don't really want to see it as a multiplication problem, but it's not wrong because didn't we see 2 sets of 6 and 2 sets of 4?
Yes.
We did see it. What do you have?
10 plus 2.
10 plus 10. So we have a 5. Where are you seeing the 5?
You add your 6 plus 4. Oh, okay, so the 6 on the top and then going down to the bottom one.
So you're making an L
on each side.
on each side. Both L's together was a 10 and a 10. I can see it. I like it. You should be adding these to your number 1. You see something?
6 plus 4 times 2.
6 plus 4 times 2.
No, it's not.
No, 6 plus 4 is 10 times 2 is 20.
No, there's a multiplication.
You gotta do multiplication first.
10 dots.
If you put the parentheses times 2,
It still wouldn't work out.
it'd be times 2.
6 plus 4 times 2. 4 times 2 is 8. 8 plus 6 doesn't get me to 20.
What if you use parentheses?
Still.
No, 6 and a 4.
6 and a 4.
Oh.
Yeah.
Yeah. It's
Then you see 2 sets of this, which I like it. I can get it. I can get with that. I see it. Let me see if there's another one that we. Yeah, there's one. There's a couple more. What?
3 plus 3 plus 3 plus 3 plus 2 plus 2 plus 2 plus 2.
That's a little extreme. I
I
have
did
to
the
say.
corners and then the middle.
How about this?
But that's what I put.
4 sets of 5. If I ignored one of the corners, I have 5. Ignore another corner, I have 5. Ignore another corner, I have 5, and then I'm left with just 5. So I could have that. What do you got?
How about 4 plus 4 plus 4 plus 4 plus 4?
Beautiful, finally. 4 plus 4 plus 4 plus 4. Is that enough?
Plus 4.
Plus 4.
5 4s.
Okay, he sees this. He sees all the middle 4s. There's 4, 4, 4, 4. Then what's left over?
Corners.
Your 4 corners. Beautiful. Okay, I'm going to move on from that. We could probably come up with a gazillion of them. I want to pick 2 of these to expand upon. And I don't want the multiplication ones or the high number ones. So pick 2. Which 2?
The 4s.
The 4s?
1 plus 1 plus 1. 5. 10 plus 5. 6 plus 10. 6
The
plus
4.
4.
This-
10 plus 10.
This one?
Yeah. No. 6 plus 10.
Alright, we'll pick those 2. Doesn't really matter.
Yes, ma'am.
Quiet.
Okay, so those are the 2 I'm going to pick and expand upon. So first I want to look at the 5 plus 5 plus 6 plus 4 strategy. I'm on B, or 2. And I am just going to diagram how I visually see that being broken up. Well, I see the 6 being broken up all the way across is 6. Then the 5s is the sides going down. You're left with 5 on both sides. Then that little middle piece, how many squares were left?
4.
4. So that's how we visually saw that expression. What was the other one we picked? All the 4s?
4.
Okay. So here is my 4s. And I want to get a diagram of that. And all the 4s, we saw all the middle sections were sets of 4s. And then you had your 4 corners left.
And you just add those.
And you just have that.
I just thought like you could take the side 4s, and so you take the bottom corner and you add 3, and then you take the next 3 and you just add the one on the other corner, and it'll be 4, and you just keep going around the 4s. That's how
Does
I
it make the same L shape every time? Or a different size L shape?
sometimes. it depends on where you start, because it can be a different
Right.
type every time.
All right. So now we're moving to question 3. Question 3 is where we're going to use our graph paper. And with our graph paper, we want to draw ponds with different side lengths. And with those ponds, we need the tile going around the ponds. So we need side lengths of a 3, 5, 6, and 7. I did 3 for you. It was a 3 by 3. Then I did my tile going around. One set of tile going around. And I'm going to see how many tiles it took to go around. And I counted it, and there is 16. So we're going to do that on our graph paper. But you're also going to do a 5 by 5, a 6 by 6, 7 by 7.
Around each other?
And seeing how many tiles is around those size shapes.
Different squares? Yeah.
Oh, yeah, not around each other.
16.
Okay, yes, we got that like 5 minutes ago. Good job.
Amazing. Yay. You said how many were around?
And I said 16 5 minutes ago. Good job. I'm proud of you.
Thank you.
Alright, so you're taking some time to draw. You should have 4 different size ponds on your paper. Count 5, 5. The main piece of information I'm looking for is how many tiles it's taking to outline my pond for these side dimensions. My board is now representing the 4 squares you should have, pond sizes you should have on your paper, and the tiles that it takes to surround your pond. Why did I skip 4? Because it was done for me already on problem 1. So I didn't need to redraw a 4 by 4. We've already looked at that one. Okay, we're going to set that graph paper to the side, and we're going to have it, it's going to be our information we're going to pull from for the next problem. So we're going to need to look at it. And A wants us to create a table and then graph it. So I'm going to make a T-chart. One side I'm going to call side length of pond, and I'm going to call it S. I normally call that column X. Why do you think they decided to choose S?
To make it complicated.
You're writing this. What does S probably stand for? The side. This column is normally called Y, but we're calling it T. And what is T probably standing for? Tiles. And we have looked at different side lengths now. We looked at a 3, 4, 5, 6, and 7. How many tiles around was the 3? 16. Looking back at my graph, there were 16 tiles around the 3 by 3. Looking at my 4, which was this question here, how many tiles was around my 4? 20. How many tiles was around my 25? 24. Around my 26, 28, and then, do you see a pattern?
Plus 4.
They're adding 4 every time. Okay? Well, I need to graph this. I have enough points to graph. So we're going to go off to the side here and graph it. look how fast I am at graphing mine. Oh, super fast. Yep. So graphing yours, labeling, make it look just like my beautiful graph.
So it doesn't.
Now I counted by 4s on my y-axis.
How is it,
The line goes.
how is it going to the origin? I don't see it.
Here's the origin. Is it going through it?
No, because it's like the origin, like finishing at the edge. And
Yeah.
why?
We're about to investigate that. Beautiful question.
How do we know 1 and 2?
Graph it. So now I'm ready to write an algebraic rule. And I'm going to teach you a trick that some teachers don't teach for some reason. It will be very helpful next year when writing algebraic rules and equations. So I'm going to take another look at a T-chart. Yes, you're writing this for B, another T-chart. But I want to look at it back at 0. So I want my T-chart to look like this. Okay, some of these numbers we had on our last table. What number did we have on our last table? 3, 4, and 5. What did 3?
16.
16, 4 was 20, and 5 was 24. I need to investigate these to help me write an algebraic rule. Well, we already noticed a pattern that it was going up by 4. So how could I figure out what 2 would be?
Subtract 4.
Subtract 4, and I would be at what? 12.
8.
Then to find 1, I subtract 4 again, and I'm at 8. To find 0, I subtract 4 again, and I'm at 4. Well, that is important to me, because is it going through the origin? No, we already saw that on the graph. So was this situation proportional? No. So we know how to write equations that's proportional that look like this. But is this proportional?
No.
That means this equation needs to have something added or subtracted to it. So it needs to have, I hear people saying, a +4 added to it. Which means, before I even started building a pond, how many tiles do I have to start out with? 4. And what is that representing in my problem? My 4 corners. Okay? Now I can look for what's acting like my constant of proportionality, and we gave that a new vocabulary word. It was called rate of change. Well, what is the rate of change happening every time?
4.
So what is acting like my K?
4.
4. That could be my equation, but there's only one issue with it.
There's 2 4s.
Nope. Pretty sure they said they wanted that called S and this called T. So I need to go through what letter is representing X? S. And what letter is representing Y? T. Math people like to use curvy T's so they don't look like plus signs. So there is my equation, and it wants us to tell us what each part represents. Well, we said what the +4 at the beginning stood for. What did the +4 stand for?
Rate of change.
There was 4 starting with.
There was 4 what?
Corners.
There was 4 corners. Then the 4s, what does S stand for again? X, which, but it also stood for side lengths. So this is saying it has 4 sets of what? Sides. So that's saying it has 4 sides. Doesn't a square have 4 sides?
Yes, it should.
So it's good, it makes sense then. That is all what B was asking for. So I had to bring my table back to 0, and this number was my magic number of what I needed to add or subtract to my equation, since it was not proportional. Big thing in 8th grade. You just did 8th grade work right there. And 9th grade.
Let's go. We too smart.
Big brain. Big brain.
Okay, I'm not done. We need to go to C, and we're going to skip it. So put an X on C, moving on. D says, is the relationship of the graph proportional or non-proportional? How do you know what is the constant of proportionality? So first question, proportional or non-proportional?
Non-proportional.
Non-proportional. How do you know?
It does not go to the origin.
It does not go through the origin. What is its constant of proportionality? Trick question. It doesn't have one. Why does it not have one? It's not proportional. So you could sum all that up. You don't have to write it in that paragraph it's showing. We said it's non-proportional because it doesn't go through the origin. And it can't have a constant of proportionality because it's not proportional. What do we say it has?
Rate of change.
Rate of change. E says, what does the point 0,4 represent? Well, normally it goes x, y, but now it's going s, t. What did S stand for? Side. So what is my side for 0,4? 0. So I have no sides. But how many tiles do I have? 4. And it asks, does this make sense with the given scenario? If I'm not going to build a pond, should I even have 4 tiles?
No.
So it really doesn't make sense. 0,4 represents 0 sides, but 4 tiles. And it doesn't make sense because you don't even have a pond to tile.
How do you tie it?
You're just doing the perimeter of it so the water doesn't come out of the pond. The second part of that question says, what does the point 1,8 represent? So what is 1 representing?
The one side.
It has a 1 side length, so it's a 1 by 1. And what is 8 telling me?
There's 8 tiles.
8 tiles will go around a 1 by 1 pond, a 1 foot by 1 foot pond. Does that make sense with the situation?
Yes, not really, but kind of.
You can't? Can you have a 1 foot by 1 foot pond?
Yes.
You probably call it just a puddle, not really a pond. But hey, if you want to have that kind of pond, okay.
Okay, buddy.
You can have, hey, it could be a glorious pond for a lizard or a frog.
Or you can stick your foot in it when you're cold.
Yeah, you can dip your toe in it.
Or poop.
And a ooch.
Still to ask.
Wait, I haven't written all of it down. I tried writing down the whole thing.
Okay, moving on to question 4. It's using the same information, and question 4 says, how can you use this rule? Our rule is t equals 4s plus 4. How can you use that to find the number of tiles needed for any size pond? For example, how many tiles would you need for a pool with a side length 5? I don't know why they said pool, because it's a pond. So, if I had side lengths of 5, how can I use this equation or algebraic rule to find my answer? Brady?
You would do 4 times 5 sides.
That's it?
Plus 4 equals t.
Okay, I don't have room down here. So, he says I'm going to substitute in 5 for s and solve my problem. So, when I solve it, I get that I need 24 tiles. So what did I do on number 4 to get my answer? Plugged in what? I plugged in my side lengths. So, to answer the first question, plug in side lengths for S. Okay, the next question, question 5. What if you knew you only had 36 tiles? So you already bought all the tiles and you had 36 of them. You want to know how big of a pond you can make with 36 tiles. How would I use my equation then? What you got, Brady?
You would use, so 36 tiles equals t.
So 36 is representing t. So my equation was t equals 4s plus 4. So where am I plugging 36 in for?
T.
T.
And then
36 equals 4s plus 4.
and then you would divide.
They didn't really ask me to solve it. They just wanted me to give it to them. So I'm done. Okay. We'll look in a second. And the last question, how could you use the graph to find the size of pond you could build with 36 tiles? So I'm using my graph. How do I look at my graph and tell that?
36 divided by 4.
I ain't looking. It says use my graph.
Oh, use your graph.
I'm going to go up to 36 on my graph. I'm going to go over. It hit there. So I'm going to draw a line down. So what would my side length be? 8 on each side. So you could either write this paragraph explaining that, or you could draw an arrow to what you did there to find it. So it's solving it? Because I have someone asking a question.
If you did 36 equals 40 times 9 plus.
Yeah, we haven't gotten there in math yet, though. We're gonna get there. All right. Thanks for listening. Like, subscribe, and hit the notification bell. Peace out, home dogs.